All right, we're past the halfway point for section 1, data representation. In this video, we're going to be focusing on binary arithmetic. So here's our learning target. Cambridge wants you to be able to perform binary addition and subtraction using positive and negative binary integers and show an understanding of how overflow can occur. Now, binary arithmetic is made easy because of 2's complement. It makes binary arithmetic very easy because you're always going to be adding numbers together. Remember, in 2's complement, you can represent a negative number, which is why you can always add the binary numbers together. For example, 4 minus 7 can be read as 4 minus 7. It can also be read as 4 plus negative 7. This is how we're going to be reading it, but instead with binary numbers. Now, the rules. There are only a certain amount of addition possibilities you can get when you're doing binary arithmetic. And as long as you remember these rules, you'll never go wrong. So the first rule is very easy. 0 plus 0, and that equals 0. When I have a value of 0, and I add a value of 0, I get 0. The next one is 0 plus 1. And that's going to come out to 1. Any value added to 0 will always be the value itself. And you can have the opposite of that. 1 plus 0 still equals 1. And then you have 1 plus 1, which often throws students off. And what happens here is you get a 0, and then you carry the 1 to the next column and you bring it down. Now, when you're looking at the binary value of 1, 0, that is the value of 2. When you're looking at the binary value of just 1, that is 1. What is 1 plus 1? 2. But in binary arithmetic, we can't write the letter 2. That would be the decimal system or the denary value. We have to write the binary value, which is 1, 0. There are 2 bits here. The first bit representing 1, which we don't have. The second bit representing 2, which we do have. The third possibility you can get is 1 plus 1, and then with a carry of 1 from a previous column. So you can have 3 ones here. 1 plus 1 plus 1. Well, that is going to equal 1, and then I'm going to carry the 1 over, and I'm going to bring it down in the next column. When I look at here, this is the value of 1. This is the value of 1. This is the value of 1. What is 1 plus 1 plus 1? It is 3. This is the binary value of the representation of 3. This would be the value of 1, which I do have indicated by the binary 1. And this is the value of 2, which I have indicated by the binary of 1. 1 plus 2 equals 3. As long as you remember those rules, you can't go wrong. All right, so let's jump into it. So we have this practice problem, 7 plus 5. It's already been written into binary for us. So what we're going to do is we're going to run through these columns, and we're going to reference back to the rules. So I have 1 plus 1. That means we're going to have a 0, and I'm simply going to carry the 1. So then I have 1 plus 1 again, because the 0, we don't really need to count. There's nothing there. So I have 1 plus 1. When I have 1 plus 1, I have the same thing. I put a 0, I carry the 1. Now we have 3 ones in a row, which means I'm going to bring down a 1, and then I'm going to carry the 1, and then we have 1 plus 0. When we have 1 plus 0, anything added to 0 is always going to be itself, not carrying anything this time, and then we have 0 plus 0, which is 0. Now 7 plus 5, doing mental math, equals 12, and we're starting off with a simple problem just so you can see how this works. Now, because this is Cambridge and we're working with 2's complement, you need to make sure that your leading number, because it's positive, starts with a 0. That's very, very important. So then we write out our values here, 1, 2, 4, 8, and then negative 16. Because remember, in 2's complement, the leftmost bit is negative. So I don't have a negative 16. I have 8 and 4, and 8 plus 4 equals 12. So we know that this answer is correct. Let's move on to a more appropriate problem. So 32 plus 21, we didn't get very lucky here. They did not do it for us. That's okay. So we're just going to fill in these values. And this time we have 8 bits, it looks like. So this is going to be negative 128. So we're just going to fill these in, and it will make converting the binary numbers and checking our answer very, very easy, because we'll be able to see the values rather than trying to figure out what it is in our head mentally, rather than me trying to explain without a visual of why it's written that way. So 32, very easy, 32. I don't need any of these other numbers. 21 is a little more complicated. Now it is a positive number, so I don't need the negative. I can't use 64, I can't use 32. I can use 16, and when I do 21 minus 16, that comes out to 5, so I can't use 8. I can use 4, and then when I minus 4, I'm now looking for 1. Okay, and with that done, we can now do our addition. 32 plus 21. When we have 0 and 1, anything added to itself is going to be, or anything added to 0 is going to be itself. Then we have 0 plus 0. Then we have 0 plus 1. That's a 1 again. 0 plus 0. 0 plus 1. 1 plus 0 is 1. And then, very, very easy problem. Now, 32 plus 21 is going to be equal to 53. Yes, it is 53. So we have 1 and 4, which is 5. And then we have 32 and 16, which is 48. 48 plus 5 is 53. So we know that that answer checks out. Our binary arithmetic worked. Let's move on to another one. So this time we have 32 plus negative 72. Okay, so for this one, we're going to do the same thing we did last time. And this time, because we have a negative number, we know that negative 72 is going to start with a 1. So let's go ahead and finish filling in these values here. So it's very easy for us to figure out what we need. All right, so we get lucky. We start with 32 again, so we'll put a 1 here. The rest are zeros. All right, negative 72 is a little more complicated. We're going to start with negative 128. It has to start with a 1 because remember we're in 2's complement, which represents a negative number. I can't use 64 because that'll get me all the way down to 64, but I can add a positive 32, and that'll get me to negative 96. So I can use a 16 because I'm looking to get to negative, I'm looking to get to negative 72. So we're at negative 96. I can use a 16. That's going to get me to negative 80. And then I need an 8, which will get me to negative 72. So that checks out, and then zeros here. Okay, so all we got to do now is, because we're working in 2's complement, there's nothing extra we need to do because we're working with a negative number. All we did was find the value of these 2 binary numbers, and we follow the same rules. It doesn't matter that we're adding a negative number. The same rule still applies. So we're going to have a 0 here, a 0 here. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 1 is 1. 1 plus 1. Now remember, 1 plus 1 equals 2. My 0, and then I carry the 1, which would be my 2. Then I have 1 plus 0, which is 1. And then I have 0 plus 1, which is 1. And this looks like it's going to check out. And the reason we know this is going to check out is when I add 32 to negative 72, I should end up with a negative number. I should end up with negative 40. This leading one says I have a negative number. So I have negative 128. I have 64. I have 16. And I have 8. When I add these 2 numbers together, I wind up with negative 64. When I add 16 plus 8 together, I get 24. I add these 2 numbers, I get negative 40. Looks like our binary arithmetic works out. And this is why 2's complement makes it so easy. All right, let's move on to another one. 95 minus 68. What do we do with an extra bit? So in this one, we, if I planned correctly, we should wind up with an extra bit. So what I'm going to do is 1, 2, 4, 8, 16, 32, 64, 128. I'll move this back so we can see it. And then this is a negative 128. Don't want to forget that because we are working in 2's complement. Okay, so this can be read, we said this can be read two different ways, 95 minus 68 or 95 plus negative 68. And we're going to read this as 95 plus negative 68. This minus sign goes with the 68. So we're actually combining 95 and we're combining negative 68. Let's start with 95. I don't need a negative 128. I do need a 64. And 95 minus 64 is going to be 31. Can't use a 32. I can use a 16. And that comes out to 15. I can use an 8. And that's going to come out to 7. I can use a 4, which will get me to a 3. And that means these two need to be filled out. And that is positive 95. Now we got to look at negative 168. So I'm going to erase this so I can get some room. Well, it's not erasing, but well, that's okay. We'll just make some room somewhere else. So we're not working with this. Now we're working with negative 68. I definitely need a 1. And the reason I need a 1 is because it's a negative number. So I have negative 128. I can't use 64. That will get me to negative 64. I need to be able to get to negative 68. So I don't need a 64. I can use a 32. And that, of course, will get me to negative 96. And then I'm trying to get to negative 68. I need a 16. So I'm going to add on 16. That comes out to 80. Then I can use an 8. That will get me to negative 72. And then I need a 4. And that will get me to negative 68, which means these can be 0. Now that I have all this written out, I can do my binary arithmetic. What's 1 plus 0? 1. What's 1 plus 0? 1. What's 1 plus 1? 1 plus 1, remember, is going to be a 0, and we carry the 1. What's 1 plus 1 plus 1? This time, instead of a 0 carrying the 1, it's going to be a 1 carrying a 1. And now I have 3 1s again. That's going to be a 1 carrying a 1. I have 2 1s, which is going to be a 0 and a 1. I have 2 1s. It's going to be a 0 and a 1. Perfect. And we are going to get the carry bit. We have a 0. But now I can't carry the extra 1. Well, that's okay. And here's why that's okay. When we're looking at 95 minus 68, and this is because we're working with 2's complement. When I look at 95 minus 68, I know I need a positive answer because I know 95 is greater than 68. If I carry that additional 1 and had it, it would say, hey, that's a negative number. Well, we don't have a negative number. We have a positive number. And what must our positive number must be? Or what must it start with? It must start with the 0. Now let's work out this 95 minus 68 and see if it works. So let's write our values above here. Oh. So let's, got to put my marker back on. Okay. 1, 2, 4, 8. Keep hitting that. I don't mean to. All right, anyway. 8, 16, 32, 64, negative 128. Okay, so we have a 16, we have an 8, that is 24, plus 2 is 26. So we have 26, and when we're looking, and then plus 1 more, got to add that other one, which is 27. So we added the 16, the 8, the 2, and then the 1. 16 plus 8 is 24, plus 2 is 26, plus the 1 is 27. What is 95 minus 68? 95 minus 68 is positive 27. So even though we didn't carry this extra bit over, that's okay. We don't need it because we're working with 2's complement. Now, that's not always going to be the case. And let's take a look at an example where it's not always the case. So this time we're going to do 82 plus 69. I'm going to do the same thing I've been doing. I'm going to write in these values, and it does not take long to write in the values. You don't want to be lazy. Trying to do it in your head, you could make a very, very simple mistake. And we have all done it. We've all tried to save, I don't know, about 15, 30 seconds of our life trying to, save time. And really 13 or 15, 30 seconds isn't really that big of a deal. It really will make sure you get the right answer. And when you take your Cambridge exam, these are questions you should get right. Okay, so I know I have two positive numbers here. Both of these are going to be 0. Now, 64 let's start with 82. I need the 64 to help get me to 82. 12 minus 4 is 8, and then this becomes 7. We have 18. To get 18, I don't need a 32. I need a 16, which will leave me 2 left over, and that is right there. So that is my binary number for positive 82. It all works out. Now for 69, I need 64, which leaves me 5, which is 4 and 1. 4 plus 1 is 5. So that will be my binary number for 69. So all I need to do now is follow the arithmetic rules. So let's go ahead and follow our arithmetic rules. We have 0 plus 1, which is 1. 1 plus 0, which is 1. 0 plus 1, which is 1. 0 plus 0, which is 0. 1 plus 0, which is 1. 0 plus 0, which is 0. 1 plus 1, which is a 0. We carry the 1. And 1 plus 0 is 1. So 82 plus 69 is, let's see here, that would be 151, I believe. I'm pretty sure it is. Let's go ahead and do some simple math. 9 plus 6, 151. Okay, we have a huge, huge problem. And that is right here. That is right here. In 2's complement, this says it should be a negative number. That's a problem. That is a big problem. And the reason it's a big problem is because when we work this out, we see that it does not come out to 151. It doesn't come out anywhere close to that. So, and then 7. 4 plus 2 plus 1 equals 7. That's where I'm getting that 7 from. So let's see here. 8 minus 6 is 2. Let's just do this one at a time. Make it a lot easier. So and then we're going to add that 7. And that's negative 105. We know negative 105 is not even remotely the same as 151. What has happened inside this binary arithmetic is what we call overflow. And the reason there is an overflow is because the maximum value that I can get with 8 bits in 2's complement, the highest I can get is 127. That is the highest number I can get. Because our number exceeds 127, I don't have enough bits to give me the answer that I need to have. I can't even get to 151 with 8 bits in 2's complement, and this is what we call overflow. It's a calculation done that is too large for the computer to store in the amount of bits necessary. Looking back here, I do not have enough bits to store 151. The maximum value I can get with 8 bits in 2's complement is 127. So any calculation that I do when I have 8 bits for the answer that exceeds 127 is going to cause an overflow. And that's what an overflow is. It's when the calculation exceeds the maximum number you can have. Once again, 151 exceeds 127. It is impossible for me or a computer with 8 bits for an answer to store 151. It is just not mathematically possible in 2's complement. So that is what overflow is. So that's it for this video. Real short, sweet. Please remember those rules. 0 plus 0 is 0. I'm going to write them down again here so you don't have to go back to the beginning. 0 plus 0 is 0. When I have nothing and I add nothing, I wind up with nothing. 0 plus 1. When I'm adding 1 to nothing, I still keep 1. I can also do 1 plus 0. When I add 1 to nothing, I still wind up with 1. Then I can have 1 plus 1. Now remember, we said 1 plus 1 is 2. So I put a 0, I carry the 1, I bring that down. And remember, this is the binary value for 2. This is the binary value for 1. this is the binary value for 1. And when I get 3 ones that I am adding, like if I carried 1 over, this comes out to 1. I carry the 1. This right here is the binary value of 3. This is 1. This is 1. This is 1. And what is 1 plus 1 plus 1? It is 3. To represent that in binary, we do 1, 1. So that's going to be it. If you have any questions, post a comment below. We'll see you guys in the next video.